Okay, so now here is an example of a function which will have slant asymptotes. So what are slant asymptotes? Asymptotes that are oblique, that is neither horizontal nor vertical. In other words, limit x approaching infinity of fx is the same as that of mx plus b. Okay, so this might be a bit difficult to understand, but fx minus mx plus b, that limit will be 0. Okay, so your function is approaching a line. That's the hope. For rational functions, slant asymptotes occur when the degree of the numerator is 1 more than the degree of the denominator. In such a case, the equation of the slant asymptote can be found. Okay. Here is an example. When the degree of the numerator is 1 more than the degree of the denominator. Okay. The domain is all of it. Notice x cannot, even if x is negative, square is positive plus 1. So you never have a denominator of 0. So the domain is everything. X and y intercepts, you can check. When y, that is this function, is 0, only numerator is 0, so x is 0. When x is 0, all of it is 0. This is an odd function. You can check. Substitute negative x and you will get negative out because of the cube. Denominator is never 0, so there is no vertical asymptote. Since fx is approaching infinity as x approaches infinity, fx approaches negative infinity as x approaches negative infinity, there is no horizontal asymptote. Okay, so now by long division, you divide x cubed by x squared plus 1, you get this. Okay, x minus, this is the remainder, and this. So long division is something you probably have forgotten. So let's try long division. Okay, so what is it that we want to divide by? We want to divide this is what is long division, right? We want to divide x cubed, so whatever is upstairs goes inside, and whatever you are dividing by goes outside. X squared plus 1. Okay, how many x squareds go here? X times x squared is x cubed. Okay, so I'm going to subtract x times x squared, that is an x cubed, and x times 1 is an x, but I'm subtracting it, so it's a minus x. Okay, so these two cancel. What is left is negative x, which is the remainder. All right, that's all they have done. When you divide x cubed by x squared plus 1, the quotient is x and remainder is this x, negative x. That's why negative x over x squared plus 1. Okay, so the quotient, I hope this is clear. Quotient is by itself. Remainder, it's not yet divided. It's not been completely broken, so you need a fraction there. Okay. So this tells me the following. Suppose I take fx minus x. I'm left with this. Now take limit of this quantity as x approaches infinity. Aha. Divide numerator and denominator by the highest power, that is x squared. 1 over x upstairs, 1 over 1 plus 1 over x squared downstairs. All of that goes to 0 over 1, which is 0. Okay. In other words, x is a slant asymptote for f. Okay. Y equals x is a slant. The rest of it is the same way. Derivatives, second derivatives, you're looking at concavity, up, down, and then eventually you graph. So notice here the function has slant asymptote, okay? No horizontal asymptote, no vertical asymptote, slant asymptote, concavity has changed. So where concavity changes, those are the inflection points. This is your x-intercept as well as the y-intercept. All right. So this completes our lecture slides. I will upload this lecture slides and then continue working on the web work problems. Okay. Until then, bye.